Beneath the surface of Earth's oceans lie regions few have reached depths where pressure crushes steel and sunlight never penetrates. In these places, instruments have detected signals with no known origin. Cameras have captured flashes of light that blink in patterns. Sonar has followed movements that leave no trace. These are not legends or rumors. They are documented anomalies recorded, reviewed, and still unexplained. What you're about to hear are some of the ocean's most unsettling mysteries. Some were captured by machines, others were logged in official records or found with no one left to explain them. No clear answers. No conclusions, just the data and the silence that followed. The bloop. In 1997, a sound unlike anything ever recorded came from the depths of the Pacific Ocean. NOAA's Equatorial Pacific Ocean Autonomous Hydrophone Array, designed to pick up distant underwater activity, caught it first. The hydrophones that detected the sound were spaced across thousands of kilometers, yet the signal was strong enough to register on multiple sensors. It wasn't a malfunction, something massive had made itself heard. They named the sound the bloop. On the spectrogram, it looked like a low-frequency burst that rapidly climbed in pitch before fading. The duration was short, just under a minute, but what made it extraordinary was its reach. No whale, no submersible, no known oceanic force had ever been recorded generating something that powerful across such a wide area. Scientists compared the frequency pattern to the vocalizations of marine animals. The structure was there. The intensity, however, wasn't. It would have had to come from a living organism many times larger than a blue whale, and nothing of that scale had ever been documented in the sea or anywhere else on Earth. The coordinates pointed to a location near 50 degrees south and 100 degrees west, placing it deep in the South Pacific, not far from the so-called oceanic pole of inaccessibility, Point Nemo. This is the farthest point from any coastline in the world. The surrounding waters are some of the least explored on the planet, with few ships passing through and even fewer research missions reaching that far. At the time of the recording, there were no storms in the region, no seismic reports, and no evidence of underwater volcanic activity. One early theory suggested a massive iceberg scraping along the sea floor could have produced the sound. Ice can sometimes generate unusual acoustic patterns, especially in polar regions, and some ice-related noises have traveled long distances before. But spectrogram comparisons showed key differences. The bloop lacked the sharp, crackling signature of typical icequakes and didn't match the frequency shifts associated with glacial pressure or friction. And while ice events are common near Antarctica, none were recorded in that specific area on the date of the sound. Public interest exploded when NOAA released the sound clip later that year. Someone pointed out that the location roughly matched coordinates from a 1920s horror story Lovecraft's The Call of Cthulhu, where a massive being slept beneath the waves in a sunken city called R'lyeh. That connection was coincidental, but it added a layer of unease. The coordinates weren't exact, but close enough to capture people's imaginations. The idea of something sleeping in the deep suddenly didn't feel like fiction anymore. Unlike other ocean anomalies, the bloop never repeated. There were no follow-up signals, no build-up before, and no echoes afterward. Other unexplained ocean sounds like Julia and Slow Down have at least been recorded more than once. The bloop was a one-time event, leaving nothing behind but a strange signature and questions that still haven't been answered. Scientists involved in the original detection, including Dr. Christopher Fox, said that although the structure of the sound resembled an organic source, no known creature could have produced it. The energy output was too extreme. Even if it were from a giant animal, it would need to exist at a size never seen before, and deep enough to remain completely undetected. That's not impossible, but without physical evidence or repeat signals, it's difficult to argue for a biological origin. As years passed, NOAA updated its website to say the most probable explanation was ice movement, likely a large iceberg dragging along the ocean floor, but even that conclusion comes with gaps. No satellite confirmed iceberg activity in that zone at the time. No known glacier was active in that region, and no supporting acoustic events were recorded nearby before or after the sound. The iceberg theory is listed as the best available guess, not a confirmed match. No wreckage, no seismic trail, no weather disturbance. just a burst of sound from the deepest part of the Pacific, loud enough to be picked up thousands of kilometers away, recorded only once, and never fully explained. Since that day, in 1997, the hydrophones have continued listening. But whatever made the bloop, it happened once, made itself known across the ocean, and then vanished. The Baltic Sea anomaly. While scanning the seafloor between Sweden and Finland, a Swedish exploration team called Ocean X captured a sonar image in June 2011 that showed something completely unexpected. The scan revealed something large and circular resting nearly 300 feet underwater. It looked symmetrical. Too symmetrical. Treasure hunter Peter Lindberg, who led the team, said he'd never seen anything like it. At first, they thought it might be a glitch. But when they passed over it again, the object was still there, unchanged. The formation was massive and early, 200 feet across, and had smooth, rounded edges that stood out sharply against the natural seabed. One part of it appeared raised, like a dome, while another section sloped downward into something that resembled stairs or terraces. A long groove stretched behind it, as if the object had skidded across the ocean floor before coming to a stop. The sonar images showed lines and angles that didn't look random. They looked designed, calculated, even mechanical. Weeks later, the team returned with divers and better equipment. The water was dark, and visibility was poor, but they managed to get close enough to take low-resolution photographs and samples. According to the team, several electronics began to fail as soon as they approached the site. Lights flickered, satellite phones dropped signal, remote-controlled cameras shut off for no clear reason. The issues stopped once they moved away from the object abruptly and without explanation. Underwater footage showed a smooth, curved surface that didn't match the surrounding rocks. Divers claimed the texture felt different from the rest of the seabed, harder in some places, almost metallic in others. Samples were taken from the site and later tested at Stockholm University. The results identified minerals like limonite and goethite, both common on the sea floor. But those tests didn't explain the object's shape or structure, or why the formation seemed to interfere with nearby electronics. The object sits in a remote part of the Baltic Sea, in international waters. No country claimed jurisdiction over it. No government released statements or sent teams to investigate. After Ocean X published the sonar scans and a few images online, the story spread quickly. It was picked up by news outlets, science blogs, and conspiracy forums. People speculated that it could be a sunken base, a crashed aircraft, or even a piece of ancient technology. Some called it the Baltic UFO. Several observers noticed that the shape resembled a fictional spacecraft. The main body looked similar to the Millennium Falcon from Star Wars, with a rounded edge and a raised central dome. The comparison wasn't perfect, but the structure did seem engineered too symmetrical and deliberate to be shaped by ice or water alone. That impression is what kept the story alive long after the scans were released, circulating on niche forums and documentary channels. Skeptics responded quickly, offering natural explanations. Many said it was likely just a rock outcrop formed by glacial activity during the Ice Age. The Baltic Sea floor contains ridges and grooves shaped over thousands of years by ice sheets moving across it. To them, the so-called anomaly was just an unusual example of that process. But even among geologists, there was disagreement. Some admitted they had never seen a glacial formation with such smooth curves or such distinct separation from the surrounding terrain. One detail often overlooked in follow-up reports is the soot-like material covering parts of the object. The divers described it as a fine, dark coating that reminded them of ash. There is no nearby volcanic activity in the Baltic region, and the sea is not known for hydrothermal vents. No official explanation was ever given for the material's presence. The samples collected didn't match any known form of sediment commonly found in that area. It was there, but didn't belong. Ocean X attempted to fund additional expeditions, but costs were high and institutional support was limited. Most universities and scientific bodies declined to participate. As a result, no high-resolution images of the full object have ever been released, and few independent dives have been conducted since. Even now, over a decade later, only the original low-quality sonar scan and a handful of blurry photographs exist, showing a massive disc-shaped structure with straight edges and strange lines. resting silently beneath one of the world's shallowest seas. The metallic rumbles of the Pacific Void. It didn't start with a scream or a splash, but just a low, metallic rumble from somewhere deep in the Pacific. At first, it was dismissed of many underwater noises picked up by hydrophones across the ocean. But this one kept coming back. It returned for years, and no one could agree where it came from or what caused it. The sound was unlike anything else in the database. It echoed like a massive steel object being dragged across metal, but the location didn't make sense. It came from a vast, empty area scientists sometimes call the Pacific Void, a zone stretching thousands of kilometers, largely uncharted, with no islands, no undersea cables, and no regular shipping traffic. Just deep water, dark pressure, and silence until the rumbles began. NOAA researchers logged the first consistent recordings in early 2014. Hydrophones positioned across the South Pacific, from near the Pitcairn Islands to points west of Easter Island, began detecting low-frequency metallic tones repeating at irregular intervals. Each burst lasted 10 to 15 seconds before fading. It sounded rhythmic, steady, pulsing, not seismic. It didn't match any known whale species, and it lacked the jagged patterns of tectonic movement. It didn't seem to be biological or geological. Attempts to triangulate the exact origin failed. One recording would suggest the signal came from thousands of kilometers west. Another placed it farther south. The timestamps didn't line up. Some suspected the signal wasn't stationary at all. Whatever it was either moving or reflecting strangely off the ocean floor. Either way, it didn't behave like a natural sound source. A research vessel from New Zealand's National Institute of Water and Atmospheric Research passed near the zone in April 2016 while conducting deep-water trawls. They dropped acoustic sensors and recorded a short burst of the rumble firsthand. The crew on board noted that some equipment on the lower deck briefly lost power during the event. One technician described a faint, reverberating vibration in the ship's hull, like something large and metallic groaning beneath them. The incident was noted in the mission logs but wasn't publicized. The data was later submitted to an internal NOAA report, where it was classified as unresolved. One paragraph described the sound as resembling heavy industrial noise in a region with no industrial activity. That part of the ocean contains no drilling stations, no undersea mining, and no established trade routes. As more data came in, the tone began to shift slightly. In later recordings, the sound took on a grinding, edgeless like dragging, more like something struggling to turn. Some bursts repeated 4 or 5 times, then silence. Other times, the sound came through once and didn't return for weeks. No one could predict it. There was no seasonal pattern, no lunar cycle, no weather link. Dr. Elias Marchand, a Canadian acoustic researcher, put forward a new theory in a 2019 paper published in a marine monitoring journal that the source could be a previously undetected undersea vent system, one releasing heated gas through metallic sediment layers, creating industrial-sounding noise. But this theory didn't account for the rumble's scale or reach. It also failed to explain why some recordings captured faint harmonic overtones, higher-pitched layers beneath the main noise, almost like tones stacked on top of one another. Machines sometimes produce those. Rocks don't. That same year, a group of independent sound analysts released a spectral breakdown of the rumble on a research forum. One of the visualizations showed evenly spaced frequency bands, clean, symmetrical, unlike the chaotic spikes caused by earthquakes or landslides. In machine terms, it resembled a heavy engine revving up and slowing down in cycles. Efforts to send a dedicated expedition to the region stalled due to a lack of funding. Private vessels refused to divert routes through the area, citing unpredictable currents and poor satellite coverage. Several launches were quietly cancelled. The area remains poorly mapped, with few reliable bathymetric scans available beyond the basics. The rumbles still occur, not as frequently as before, but just often enough that the files continue to grow. The most recent confirmed recording was in late 2022, captured by a hydrophone array maintained by French Polynesia's marine monitoring program. It lasted 12 seconds, same tone, same metallic resonance. Still no clear source. The whistle from the Mariana Trench. Something strange was buried deep in NOAA's hydrophone recordings, an eerie sound that didn't resemble seismic activity or marine life. It started with a low moan, rose sharply into a melodic whistle, then dropped off into silence. It was first noticed in 2016 by scientists reviewing data from the Pacific Marine Environmental Lab. The sound didn't match anything in their archives, and no one had heard anything quite like it before. Positioned in the Challenger Deep, the deepest known part of the trench, the hydrophone that captured the signal was operating in near-freezing temperatures under crushing pressure. Most of what lies down there remains unmapped, unreachable, and largely unknown. Temperatures are near freezing. The pressure is over 1.0 times greater than at sea level. Few machines can survive it for long. Human divers certainly can't. The sound lasted about 3.5 seconds. Its structure was clear, a low-frequency tone that suddenly shot up into a much higher pitch before falling again. That upward sweep was the most unusual part. Most natural ocean sounds don't follow that curve. Earthquakes, landslides, or volcanic activity tend to produce chaotic, spiking vibrations. Animal calls like whales or seal shave signatures that repeat or fluctuate within certain ranges. But this one was smooth, consistent, and oddly clean. Analysts later gave it a nickname, the Western Pacific Biotwang. They noted that it shared some characteristics with baleen whale vocalizations, particularly those made by minke whales. But there were immediate problems with that theory. First, the sound's frequency and duration didn't fully align with any known minke call. Second, it was recorded at extreme depths far deeper than where minke whales are typically found. And third, the structure was too simple. No harmonics, no layered clicks or pulses. Just a single, eerie whistle that didn't vary. Researchers published a brief paper later that year, outlining the sound's characteristics and inviting further investigation. But nothing definitive ever came out of it. No other research team stepped forward with a matching recording. No follow-up paper identified the source. And despite being monitored continuously, the sound hasn't been recorded again, not from that site or anywhere else. One detail buried in the report caught the attention of a few independent analysts. The hydrophone that picked up the sound was only recently deployed when it captured the signal. It hadn't been in the water for more than 48 hours. The whistle occurred in that short window, and then never again. That coincidence coming so soon after activation bothered some observers. If it were a routine animal call or geological event, why had no earlier deployments detected anything similar? Another strange aspect was the signal's clarity. Ambient noise in the trench is usually chaotic. Currents, distant seismic activity, and even the slow movement of sediment on the seafloor all produce background noise. But this recording came through with almost no interference. It was crisp, focused, like it came from something nearby, and something deliberate. There were no submarine operations scheduled in that area, no naval tests, no equipment failures or misreadings reported. The hydrophone was functioning normally before and after the event. NOAA ruled out mechanical error. It wasn't feedback, it wasn't distortion, and it wasn't electronic interference. Whatever made the sound, it happened in the water. A few marine biologists suggested it might be an unknown species, something adapted to the trench, capable of vocalizing at extreme depths, but others pushed back. There's no evidence of vocal marine mammals at those levels, no observed signs of communication, no remains, no visual confirmation of anything large enough to produce a sound like that under such pressure. And yet, the sound exists. The full recording remains public. It's only a few seconds long, but even in that short span, it feels unnatural. There's something almost artificial in its rise and fall, like a coded signal or a mechanical calibration. It doesn't stutter or waver like most biological calls. It doesn't echo like geological events. It just rises, holds for a moment, and vanishes. After years of monitoring, no second occurrence has been recorded. The whistle came once, in one of the deepest and most unreachable parts of the planet, and never returned. Scientists still don't know if it came from an animal, a machine, or something else entirely. They just know it was there briefly, and then it wasn't. The unexplained flashes of Te Lapa. Out in the open waters of the South Pacific, where the sea stretches undisturbed for hundreds of kilometers, people have long spoken of something strange, something that shouldn't exist. At night, in complete darkness, sudden flashes of light appear underwater. They don't glow like bioluminescent creatures. They streak like lightning, shooting through the water in a fixed direction. The people of Fiji, Tonga, and the Solomon Islands have known about them for generations. They call it te lapa. The lights don't hover or pulse. They move fast, always in a straight line, and they don't come from the sky or the horizon. They rise from the sea itself, starting beneath the surface and pointing toward land, sometimes toward islands that are far beyond the visible line. According to traditional navigators, te lapa appears most often on clear nights with no moon. The flashes are brief, just fractions of a second, but they return, one after the other, always moving the same way. Western documentation of te lapa began late, despite centuries of local knowledge. In 2009, an expedition led by ethnographer and sailor Marianne George joined a group of Polynesian navigators to observe the phenomenon near the island of Taumako. The team expected myth or misinterpretation. What they witnessed instead were clear, narrow beams of light streaking beneath their boat, unconnected to stars, clouds, or any atmospheric source. The lights pointed directly to nearby islands, sometimes ones more than 30 kilometers away. Recording the flashes proved difficult. They moved too quickly, and their intensity was too faint for standard equipment. In one instance, a high-speed low-light sensor captured a trace of the beam, just a narrow streak along the lower edge of the waterline, disappearing in the same direction every time. The lights came from below the surface, not above, and they didn't reflect or scatter like normal light. They sliced through water with unnerving precision. A marine biology team proposed that it was undersea bioluminescence, triggered by pressure shifts in deep channels. But no known organism behaves this way. Bioluminescent life forms either pulse or radiate. They don't move in silent, linear streaks over long distances. Another suggestion was that it could be some kind of electrical discharge, something like St. Elmo's fire, but those need atmospheric conditions, and te lapa only appears on clear, still nights with no storms nearby. In one nighttime observation, a flash appeared multiple times over 40 minutes. It came at a consistent angle each time, pointing toward a specific island beyond the horizon. The boat had no lights on. There were no other vessels within range. The water was still, yet the beam continued faint, sharp, and unwavering, like a signal from something deep and unseen. Traditional navigators trust te lapa and use it to find islands across the open ocean when stars are hidden or GPS is unavailable. To them, it's not a mystery. It's a function of the sea and not yet fully understood, but no less real. They describe it not just as light, but as a current of energy moving through the water, visible only under exact conditions, and invisible to those who don't know where or when to look. One of the most puzzling features is how te lapa behaves underwater. Light usually diffuses in salt water. It bends, scatters, and loses focus. These beams don't. They travel in a straight, defined line, as though they aren't light at all, but something else, something using light as a visible trace. Some observers reported a low vibration when the flashes passed, a soft pressure under the skin like a pulse, or the static hum of nearby equipment, but there was never any heat, no radio interference, no electrical spike. There is no known equipment capable of producing underwater beams that behave this way without a visible source. Yet te lapa appears without warning, without structure and explanation. It doesn't align with undersea cables, fault lines, or hydrothermal vents. It has no schedule, no known pattern. The logs of the 2009 expedition remain stored in limited access archives, occasionally reviewed but never formally published. No follow-up missions have been announced. Among oceanographers, the flashes are a rare curiosity, but for navigators still guided by waves and memory, te lapa is not a question. It is a fact seen, used, and unexplained. The crater that appeared overnight, Azores. Fishermen from the island of São Jorge were the first to notice something unusual just before sunrise. The water near a familiar patch of sea had changed. It churned in place with no wind to stir it. By mid-morning, a large circular crater had appeared in the ocean, visible from the cliffs above. It wasn't a sinkhole, it looked more like a pit torn into the sea itself, a wide depression where the water swirled without settling or spilling over. This happened off the coast of the Azores in April 2020. The exact location sat between São Jorge and the smaller island of Pico. Locals initially thought it was a whirlpool, but satellite images taken 2 days later showed something more stable, a dark ring nearly 80 meters across, darker than the surrounding water, with sharply defined edges. No plume, no eruption, no disturbance on the surface, just a perfect circle that hadn't been there the day before. Oceanographic teams from Ponta Delgada tried to investigate, but reaching the site proved more difficult than expected. Sonar scans showed an abrupt drop in the seafloor nearly 30 meters down, as if part of it had caved in, but the slope didn't match volcanic crater profiles common to the region. The Azores sit on the mid-Atlantic ridge, where seismic activity is frequent, yet no earthquakes had been recorded in the area in the days or weeks before the formation appeared. One research vessel, Mar Leste, experienced bursts of static on open radio channels, despite no cloud cover, lightning, or wind. Divers were eventually sent from the University of the Azores. Their descent was cut short after several instruments began malfunctioning. Depth sensors blinked out at 40 meters. Cameras picked up flickering light distortions and stopped transmitting entirely. One diver described a humming sensation in his chest as he got closer to the depression, like a vibration pressing inward. He returned early. His dive computer showed no decompression anomalies, but the recorded dive time didn't match his teammates' log. Neither could explain the difference. Water samples taken near the rim showed slight increases in iron and dissolved gas levels, but nothing outside the norm for volcanic islands. No signs of heat, no bubbles, no sediment cloud, no unusual salinity. Surface temperatures were lower by just under 0.5 degrees Celsius. Whatever had happened left no thermal signature and no visible disruption. Yet the shape remained precise, unmoving, and unaffected by the usual tides or currents. Some researchers suggested a caldera collapse, but that would have left fractured terrain or loose material. Others proposed a gas vent opening beneath the crust, creating a temporary vacuum. But that kind of event typically causes turbulence, discoloration, or surface bubbling. This left nothing. Marine life in the area disappeared for more than a week. The usual schools of jack mackerel, bluefish, and even jellyfish that often drifted near São Jorge were gone. Local fishermen stayed away. Some claimed their compasses spun as they neared the coordinates. GPS systems froze or lagged without warning. One boat lost engine power just as it reached the outer edge of the ring. A retired captain said the site reminded him of something he'd witnessed decades earlier, an oily slick that shimmered and pulsed before breaking apart. Radio signals often dropped for several minutes near the site, returning only when boats turned back. The Portuguese Hydrographic Institute deployed a towed sonar array to scan the formation's interior. Midway through the dive, the array disconnected from the main line. The recovery cable came back uncut, but the sensor module at the end was missing. There were no signs of force, tearing, or damage. The mission was cancelled, and no follow-up expeditions were approved that year. Unofficially, several researchers said they weren't comfortable returning to the site. By early summer, the depression began to fade, not suddenly, but gradually, over several days. The sharp edges softened, water clarity returned, currents resumed. By July, the formation had nearly vanished from satellite view. Regional maps labeled the area Zone Irregular. Fishing boats avoided it, even after the shape was gone. No official explanation was issued. Photographs, dive logs, and sonar recordings were quietly archived. News of the event never made national headlines, but the story spread across marine forums, shipping channels, and island radio broadcasts. It has never happened again. The Devil's Sea. Somewhere south of Tokyo, a Japanese cargo ship named Keio Maru No. 5 disappeared without warning. The crew had been assigned to survey a section of the ocean that had long unsettled local fishermen. No radio call was made, no debris was found. The ship vanished along with 31 people. It had been part of a government effort to study unusual seismic patterns and magnetic drift in a region some already called cursed. This wasn't the first disappearance. At least 5 other ships went missing in the same zone between the late 1940s and early 1950s. No survivors, no wreckage, no clear pattern. Maritime authorities noted the incidents but never issued official warnings. Sailors began calling the area Mar no Umith Sea of the Devil. It forms a rough triangle between the coast of Japan, the Bonin Islands, and the Philippine Sea, overlapping a section of the Pacific known for tectonic activity, but also for something less measurable. The weather in the region can turn violent fast, but many reported these vanishings on calm days. Survivors from earlier close calls described sudden stillness before instruments failed. Compasses spun slowly, then froze. The radio dropped to static. Some boats reported hearing metallic hums from beneath the hull, as if something massive passed under them without breaching the surface. None of these stories could be verified, but they were told often enough that captains started adjusting their routes. A transport plane flying over the area once vanished from radar for nearly 12 minutes before reappearing 70 kilometers off course. The pilot later said he experienced no mechanical problems, yet flight records and fuel usage didn't match the aircraft's final position. The altimeter readings appeared normal throughout the disappearance. Officials listed it as a brief signal dropout. Older maritime logbooks suggest that strange occurrences in the area go back much further. One British whaling crew in the 1870s recorded a vertical mist wall that surrounded their ship for hours, blocking both moonlight and stars. The captain marked the coordinates and described hearing a rhythmic knocking from beneath the water, something that echoed through the hull like metal against metal. A Japanese cargo vessel reported passing through a low-lying fog bank that disrupted its magnetometer during a routine voyage in 1958. The reading fluctuated by 15 degrees before settling, then repeated the same deviation at the same coordinates on a return voyage 3 weeks later. Engineers on board ran diagnostics and found nothing wrong with the equipment. The crew made a note of the incident but never reported it officially. Japanese naval vessels later reported sonar interference in a consistent circular pattern, roughly 40 kilometers wide. Every pass through the region created jagged, unreadable sonar returns, even though nearby scans were normal. Attempts to drop buoys failed, several detached within minutes, their tethers cut clean as if by heat or force. One crew said a deep thud followed the last release, like something catching the buoy line and pulling. Oceanographer Dr. Yasuhiro Tanaka tried to map the region's magnetic anomalies using fluxgate magnetometers and early satellite measurements. His team identified 2 zones where geomagnetic drift exceeded 10 degrees. Neither site had volcanic rock or known metal concentrations. One anomaly was located just south of Hachijojima. The second appeared over a basin with no detailed bathymetric scan. The project ran out of funding before they could return with updated sensors. A fishing trawler reported sonar pings showing 2 seafloor sewn flat, one curved about 20 meters apart. The operator said it looked like something massive had settled just beneath the sediment, but every attempt to scan it again failed. Divers refused to enter the water. The vessel avoided the area after that. During a 2003 expedition out of Yokosuka, a research team lost main power while nearing the region. The backup system came online without showing any malfunctions, but multiple dive recordings from the mission were later found to be corrupted. One technician reported seeing a sharp flash beneath the surface just before the blackout. No movement, no sound, only a vertical beam that blinked out in seconds. Today, the Devil's Sea remains unmarked on official hazard charts. The area is still crossed by commercial vessels, but many captains choose longer routes to avoid it. No laws force them to, but the habit persists. They say the sea there feels too quiet, too empty, like something is just waiting underneath. The black silhouettes of the Philippine Trench. Fishermen working off the coast of Mindanao told stories that didn't make sense. Some claimed to see enormous, slow-moving shapes rising just beneath the surface before vanishing again into the dark. No fins, no glow, just black masses that drifted silently beneath their boats, leaving no wake and no splash. Nets returned empty, tangled, or torn clean through. The shapes made no sound, yet left an impression that something large was watching from below. It only seemed to happen near the drop off the edge where the shallow shelf falls sharply into the Philippine Trench. The trench drops over 0 meters, and much of it remains unmapped. Unlike the Mariana Trench, which is frequently surveyed, this stretch of the ocean has fewer expeditions, fewer sensors, and fewer explanations. Every once in a while, a crew would stop returning. Sonar scans from commercial vessels crossing the area have shown brief flashes of movement near the edge of the abyss. Not fish, not whales. One report described an oblong mass the size of a school bus moving vertically, without propulsion. Another described multiple returns-identical shapes drifting in formation, too deep for light to reach, yet too close to the surface to ignore. A university team from Manila deployed a submersible drone along the outer trench wall in 2015, hoping to collect samples near a suspected methane vent. Halfway through the descent, the drone's camera captured something moving across the background flat, angular, and perfectly dark, blocking out all visible light. At first, they thought it was a shadow until it moved in the wrong direction. The object passed without interacting. It didn't swim, it slid. The drone lost signal 10 minutes later. When it was pulled back up, the outer casing was dented. The manipulator arm was missing. There was no corrosion, no burn marks, no damage consistent with pressure failure, just a clean break, as if the arm had been torn or snapped. The team logged the anomaly and left the area early. It was the only time that particular submersible ever suffered structural damage on a routine dive. One sailor aboard a cargo vessel headed to Davao claimed he saw something during a night shift 5 silhouettes drifting beneath the ship, spaced evenly apart. He thought they were whales, until he realized they weren't surfacing. They moved as a group, wide and slow, each one barely breaking the surface tension before slipping back down. He watched for nearly 2 minutes before they disappeared into deeper water. The crew dismissed his report. No official statement was ever filed. An acoustic technician with the Philippine Institute of Volcanology and Seismology picked up an unusual low-frequency pattern while monitoring tectonic rumbles along the trench. The wave came in layers, with one part steady and one pulsing. It resembled sonar-long, drawn-out tones with sharp ends, but it didn't match any known vessel. It repeated at intervals not used by shipping traffic. There was no return ping, only the broadcast, like something was listening but not responding. The silhouettes gained attention on online forums where satellite tracking enthusiasts noticed disruptions along certain routes. A few infrared sweeps from open-source weather satellites showed brief cold spots moving just beneath the surface. Meteorologists called them compression artifacts. But the shapes returned in later scans, always in motion, always in the same place. A thread about the phenomenon reached over 1,000 posts before being deleted from one marine research forum with no explanation. A Japanese survey vessel revisiting the region in 2019 reported several of their underwater drones experiencing rapid pressure fluctuations and transmitting static. The mission log mentioned unexpected ballast drift and subsurface displacement. Officially, it was blamed on an undersea landslide, but the slope beneath them was flat. The drones were recovered, but 3 of the memory cards had been wiped clean. Several researchers proposed that the trench's geography might create illusions, temperature layers, sudden shadows, lensing effects, but those theories didn't explain the missing equipment. They didn't account for sonar readings that showed objects too large to be fish, too smooth to be volcanic, and too quiet to be mechanical. And they couldn't explain why fishermen who had worked those waters for decades had begun to turn back before reaching the edge, not because of storms, not because of pirates, but because something out there moved when nothing should. The murmuring ocean floor. It started as a background hum, barely noticeable, just a faint, low vibration picked up by deep-sea hydrophones anchored along the Cascadia subduction zone. The sensors had been placed there to monitor tectonic activity along the Pacific Northwest, and for weeks in early 2021, they recorded a sound that didn't match any known seismic pattern. It was continuous, like a whisper carried through stone, rising and falling in slow waves. When the audio was reviewed by marine geologists, some initially thought it might be a malfunction, but the murmuring wasn't coming from one sensor. It was picked up across multiple arrays, spread over 300 kilometers of seafloor. Each recording had the same signature, a modulated, low-frequency tone with slight fluctuations, consistent enough to track but too irregular to classify as tectonic motion. There were no tremors, no quakes, no volcanic activity, just sound. Instruments located off the coast of Oregon and Washington detected the same signal at staggered intervals, as if the source was moving, shifting slowly across the seafloor. It didn't pulse like whale song, nor did it echo like sonar. It lacked the sharp edges of mechanical noise. One technician described it as a deep, breath-like murmur, too steady to be alive, too soft to be a machine. The murmuring continued through mid-February, at times growing louder before fading to near silence. Then it would return, unchanged. NOAA researchers attempted to isolate the sound and compare it to archived data. Nothing matched. It wasn't thermal vent activity, nor sediment shifts. One spectrogram showed subtle, harmonic layering faint overtones stacked on top of the main signal, spaced with eerie precision. That pattern didn't appear in any of the surrounding geologic recordings. It came only from the stretch between the Juan de Fuca Ridge and the trench. A research vessel, Ewing Grace, was dispatched to the area in March with a team from Oregon State University. They deployed a series of underwater microphones and autonomous gliders to follow the sound. As they tracked the signal southwest toward the edge of the abyssal plain, the volume remained steady, but the direction kept shifting. Sometimes it came from below the vessel. Sometimes it moved laterally, as if slipping between layers of rock beneath the sediment. One of the strangest observations came from a remotely operated vehicle sent 20 meters down. As it neared a section of uneven seafloor, the vehicle's feed began picking up faint vibrations, not as sound, but as image distortion. The camera flickered, the frame shook slightly. The operators thought it was a mechanical issue until the vehicle moved away from the area and the image stabilized instantly. They ran diagnostics. No faults were found. That same dive recovered a sample of crust material from a narrow trench marked by sonar anomalies. The rock was ordinary basalt, but embedded within it were microscopic bubblestony, spherical voids, completely sealed, with no known explanation. When analyzed under pressure, the bubbles didn't collapse, they held their form. A metallurgist brought in to assist the analysis remarked that the structure was unnaturally uniform for something buried in sediment for millennia. After weeks of study, the sound continued, never intensifying, never vanishing, just murmuring beneath thousands of meters of water. Some at NOAA considered the possibility of a slow rupture forming deep below the crust. Others proposed a deep-sea resonance effect, where cavities in the rock might amplify distant seismic noise. But these were working theories, not conclusions. No known event or system could account for a signal that persisted without variation for weeks. A separate team at Woods Hole Oceanographic Institution ran an amplitude scan of the signal. They noticed a pattern that repeated every 19 hours and 17 minutes. Not linked to the tide, not lunar. Nothing in the database explained that interval. It wasn't perfect, but it was enough to suggest intentional timing, like a beacon or coded emission, faint and slow enough to be mistaken for background noise. During one particularly strong murmur, an offshore cable relay used for ocean data transfer dropped signal for 7 minutes. The relay wasn't damaged, and data resumed normally afterward. But in that brief window, several internal clocks reset themselves to default. That's not supposed to happen without a hard reboot. By April, the sound began to taper off, not all at once, but gradually, like it was receding into the crust. Some instruments continued to pick up faint echoes into May, but they grew weaker and more erratic until there was nothing left to track. The sea floor, once again, went quiet. The disappearing submarine of 1968. For several days in May 1968, French Naval Command tried to make contact with one of its submarines, Minervia, 57-meter diesel-electric vessel carrying 52 crew members. The last transmission had been routine, a position report, no sign of distress. The weather off the coast of Toulon was rough but not unusual for that region. When no further contact came, a search was launched. Ships and aircraft swept the area for signs of wreckage, oil, or debris. They found nothing. The disappearance happened just 25 miles off the French coast, in waters that were considered well charted and relatively shallow. If there had been a mechanical failure, the submarine should have been recoverable, but no emergency beacon had been triggered, no signal buoy surfaced. The only clue came from a sonar station on the French mainland, which picked up what it described as a metallic implosion around the estimated time of the last transmission. Other nations took an interest. At the time, 1968 had become an unprecedented year for submarine disasters. Just weeks earlier, the the Israeli submarine Dakar had vanished in the Mediterranean. Not long after Minerve, the Soviet K-129 and American USS Scorpion would also be lost under murky circumstances. None of the incidents appeared directly connected, but the proximity of events raised questions. Some suggested sabotage, others pointed towards silent underwater collisions during covert Cold War operations. Despite France's urgency, the seabed where Minerve had last been tracked turned out to be more complex than expected. The slope dipped into a rugged stretch of underwater terrain filled with folds, trenches, and rock towers. Submarines weren't supposed to operate there, and few had mapped it in detail. French recovery ships spent weeks scanning the region with sonar but got inconsistent returns. Each time they thought they found something promising, the object turned out to be a boulder or geological formation. A deep-sea robot was eventually lowered into the suspected area. It malfunctioned after 5 hours and returned with degraded footage and temperature anomalies that couldn't be explained. The dive log noted sharp pressure fluctuations around 2.0 meters too deep for Minerve to have descended without catastrophic failure. And yet, some of the scans hinted at metal reflections at that depth. There were no black box recordings, no distress code was ever sent. Families of the crew were told only that the submarine had vanished and likely imploded due to a sudden structural failure. Internally, French officials remained divided. Some believed the sub had descended too fast during a practice dive. Others suspected that a nearby NATO exercise had accidentally jammed communications and scrambled navigation. One theory suggested a secret tracking device might have failed, misleading the recovery effort entirely. A private salvage company reported a sonar contact not far from the original search Greda cylindrical structure buried halfway into a sediment slope. The detection happened during a limited sweep in 1970 using older side-scan equipment. Before they could return with verification gear, a storm swept through the area and disrupted the seabed. When the team came back months later, the signature had vanished. No structure, no reading, nothing left to trace. Whispers persisted within naval circles. A few former sonar operators claimed off record that strange sounds were picked up in the days after the disappearances, low, metallic echoes that repeated at intervals, coming from below the known crush depth of the submarine. These accounts were never verified and never included in official reports. The French Navy quietly closed the case by the early 70s, declaring the vessel lost with all hands. For over 5 decades, the wreck of Minerve remained unfound. Then, in July 2019, a new survey using advanced drone-based sonar finally located the submarine's remains, shattered but largely intact, resting 350 meters beneath the surface. It had somehow traveled farther and deeper than anyone had estimated. But the cause of its descent, and the reason no wreckage had been visible in previous scans, were left unresolved. Some parts of the hull were strangely twisted, as if compressed from multiple angles at once. No one could say why no emergency signal was ever sent, or how the implosion so clearly picked up by sonar in 1968 didn't scatter more debris. Most of the vessel remained sealed. Instruments had corroded beyond use. The final moments of Minerve still aren't known, only that it sank straight into silence and stayed hidden for 51 years in waters that had been searched again and again. The saltwater skeletons of Andaman. A diving group off the west coast of Little Andaman spotted something strange near the edge of a coral shelf. One diver surfaced early and reported seeing what looked like bleached branches caught in a rock crevice pale and tangled. When the rest of the group descended to investigate, they realized they weren't looking at coral or driftwood. The shapes were bone. The remains weren't buried or scattered. They were standing vertically. Entire rib cages upright in the sand, some tilted, others perfectly aligned with the slope of the seabed. Skulls rested nearby, partially embedded in silt, with jawbones still attached. No clothing, no rope, no tools, just bones, hundreds of them, preserved in salt water, untouched by sea life. After surfacing, divers marked the coordinates and sent word to the local port authority. Within days, a naval patrol from Port Blair sent a small research unit to verify the site. Their initial report logged 31 complete skeletons and dozens of fragmented remains, all within a 60-meter radius. They described the layout as unnatural, not shipwreck debris, not burial mounds, and not the result of currents or landslides. Marine biologists from the National Institute of Oceanography reviewed photos and noted how the bones appeared unusually clean, without typical signs of erosion. One commented that the vertebrae still retained alignment, even in the absence of soft tissue. That kind of preservation, in warm saltwater, should have been impossible without embalming or sealed burial. These skeletons were exposed, resting openly along the seabed. Efforts to carbon date the material proved problematic. Some bone samples showed signs of degradation, and others returned inconsistent readings. One test dated a femur to the 14th century. Another, from a rib bone found 2 meters away, came back as less than 90 years old. The lab performing the analysis suggested the samples may have been contaminated, but the team hadn't touched them with bare hands, and retrieval methods followed protocol. There were no historical records of a mass drowning in that exact area, no shipwrecks large enough to explain that number of remains. Fishing records from nearby villages didn't mention missing fleets or storms severe enough to wipe out that many people at once. The region isn't far from the route used by the British Navy in the 19th century, and one theory proposed that the bones belonged to indentured laborers or prisoners dumped at sea. But no official log matched the location, and none of the recovered skulls showed signs of trauma. Divers returned several more times over the next 6 months. Each visit revealed new patterns. Some bones had shifted slightly, but others seemed to rise between dives' new ribs and vertebrae protruding from the sand as if something underneath was pushing them up. Cameras left overnight showed nothing unusual. Yet each new scan added to the total count. By the end of the year, 53 full skeletons had been catalogued. No clothing fibers, no personal items, not a single coin, button, or buckle. One of the dive team leaders mentioned an odd auditory effect when near the site. He claimed that at certain depths, you could hear a faint clicking or whispering just on the edge of the water's natural sound. Not bubbles, not sonar, something soft and repetitive, like murmurs passing through the current. Audio recordings picked up nothing, though several divers independently mentioned the same effect. A marine geologist working with the team noticed that the sediment below the skeletons was unusually loose, like it had been disturbed repeatedly. Beneath the silt, sonar registered hollow pocket-small voids less dense than the surrounding terrain. No one was allowed to dig deeper. The pockets were unstable, and the risk of collapse was too high. The Indian Navy eventually placed a no-dive advisory over the area, citing fragile reef structure and safety hazards. Most of the documentation remained classified. Only a few blurred images leaked online, often mislabeled or ignored. Skeptics dismissed them as manipulated or misinterpreted, but the coordinates never changed, and the bones never disappeared. Locals from Hut Bay refer to the area in quiet tones. A few older fishermen claim it's cursed something about lights that flicker just below the surface, or boats that lose direction when they pass over the spot. No one's seen the lights firsthand, but they avoid the water there anyway, not out of fear, just instinct. The breathing hole of the South Atlantic. A weather satellite picking up routine thermal readings over the South Atlantic logged an unusual signal just before dawn. Near a calm patch between Tristan da Cunha and the Mid-Atlantic Ridge, one infrared band showed a circular zone where the surface temperature shifted rhythmically cooler, then warmer, then cooler again. The pulse repeated every 4 minutes for nearly an hour before fading completely. No ship was present, no storm was forming. The ocean appeared still. A week later, a fishing trawler crossing the same corridor reported what the captain described as the ocean exhaling. Just after midnight, the water directly beneath the vessel rose slightly not from a wave, but as if the sea itself had expanded. A low hiss followed, like pressurized air escaping from beneath the surface. Then nothing. The crew saw no gas bubbles, no debris, no bioluminescent glow. They left a buoy at the site and moved on. The buoy's data was sparse. Currents were mild. Temperatures stayed within the expected range, except for a brief dip of 0.6 degrees Celsius that lasted fewer than 3 minutes. Pressure sensors recorded one fluctuation too large to be a fish, too small for tectonic movement. It didn't repeat. Researchers reviewing the data flagged it for further analysis, but moved on when no matching events were found elsewhere. 6 months passed before a French research vessel mapping part of the Mid-Atlantic ridge passed over the same coordinates. A technician monitoring sonar noticed a shallow depression on the sea floor, circular indentation roughly 30 meters wide, smooth along the edges, and deeper in the center. The formation wasn't on any previous maps. It wasn't volcanic or glacial. Sonar sweeps picked up something odd just beneath it. A hollow chamber. Not a cave, not a vent, just a space, sealed off from the surrounding rock. As the ship moved away, a loud thud echoed through the hull. The crew assumed it was an anchor shift or ballast movement, but nothing on board had changed. Internal sensors showed a mild shock wave coming from below. When they ran sonar again, the chamber was gone. The depression remained, but the void beneath it no longer showed up. One team member compared it to a lung collapsing. Nothing was made public. The event was logged in a private maritime report shared with a few geological institutions. But rumors surfaced online months later when satellite tracking hobbyists spotted recurring heat signatures near the same coordinates. Not consistent, not frequent, just 1 or 2 a year, always at night, always brief. The temperature pulses matched the original reading, circular, faint, and oddly timed, like something beneath the water was cycling. One marine biologist from Cape Town tried to match the data with known animal migrations, hypothesizing that large deep-diving whales might disturb sediment or gas pockets. But the hole's pattern didn't align with any biological schedule, and no animal was large enough to trigger the pressure shifts noted by the research vessel. The noise wasn't biological, it wasn't volcanic, and it wasn't linked to currents or weather. A drone operated by a private oceanographic firm captured brief footage in 2021 of the surface ripple near the same site. The water didn't rise or swirl, it flexed. A shallow dome formed, held for a few seconds, and then receded, leaving the sea completely flat. The video never went viral, partly because the company pulled it offline within hours. Copies exist, but they're low resolution and mostly dismissed as edited or misinterpreted. Divers have never gone down to the exact site. It lies too far from support stations and too deep for casual descent. Most institutions show little interest, citing limited data and the risks of sending equipment into unmapped terrain. But several survey crews have reported transient issues when passing nearby. GPS delays, magnetic fluctuations. One even claimed that their winch cables tightened momentarily without tension from below, as if something pulled briefly, then let go. Older fishermen from nearby territories, St. Helena, Ascension sometimes mentions a place where the ocean breathes. They describe it as a calm zone that hums softly on still nights. No one gives coordinates. No one lingers when the hum begins. The site isn't officially marked on any charts, but the depression still appears on sonar. Round, still, waiting. The silent zone. Radio technicians aboard a Chilean weather monitoring vessel first noticed it. Somewhere off the Nazca Ridge, every signal they sent across a certain frequency range returned kleno, echo, no noise, just silence. It wasn't interference because the instruments were functioning properly, but when aimed toward a specific quadrant of the South Pacific, the response was total dead air. Even the natural background static seemed to vanish. The ship's crew rechecked their systems, switched antennas, and rotated bands. The silence persisted in one direction only, and it was sharp, like someone had drawn a line through the sea. Outside that line, everything functioned. Inside it, nothing. Word of the anomaly circulated through the small community of oceanic communication analysts. A few skeptics blamed solar weather or magnetic disruptions, but nearby vessels reported no such issues. One Japanese cargo ship, passing through the same corridor days later, logged a temporary blackout on its navigation radar. The sky had been clear. The ocean is calm. Yet their system stopped tracking returns for 13 full minutes before blinking back to life. A Brazilian submarine conducting drills in the region also picked up something strange more precisely. They failed to pick up anything at all. Their passive sonar array, usually filled with the constant crackle of marine life and water movement, dropped into dead silence as they passed through the zone. Not a whale call, not a current, not a single ping, just pressure and blackness. Later, Analysis of their onboard logs showed an odd temperature flattening across the area. Ocean temperatures usually vary with depth, but here, for nearly 6 kilometers straight down, the readings showed a single, stable band. No thermoclines, no fluctuations. Just one long vertical strip of uniform water. That pattern had never been recorded anywhere else in the region. Remote buoys dropped into the zone fared no better. Those that stayed functional sent back almost nothing, no movement data, no sound data, only static pressure and temperature logs. A few were recovered later with odd scarring on their hulls. One had its antenna bent nearly flat, as if pressed from above. No signs of collision or animal contact, no burn marks, just silent damage. Marine biologists attempted to survey the region using baited cameras. The footage from the first 2 drops showed drifting sediment, a few small shrimp, and then sudden blankness. The cameras stopped recording mid-drop. Power was intact, but the video feed vanished. One device showed a sharp spike in internal pressure before cutting off entirely. When pulled back up, its casing had cracked, despite being rated for far deeper water. A Norwegian seismic survey team operating south of the area picked up strange data patterns from their towed array. Instead of echoes from the sea floor, the returning signals formed blank columns, vertical stripes of missing data, as if something in the water had swallowed the pulse. They checked their cables. They replaced the sensors. The columns returned. None of these incidents were widely reported. Most appeared only in maintenance logs, internal memos, or declassified navigation briefs. But the pattern was clear to anyone who looked. The same patch of ocean, stretching roughly 300 kilometers wide, was muting sound, deflecting signals, and damaging equipment without warning. It didn't move. It didn't grow. It just remained. Local fishing crews from Peru and Ecuador had long avoided the zone. They didn't have a name for it, but their routes curved wide around its edges. Some claimed the water there made their skin itch. Others said engines ran rougher or nets came up twisted. Stories varied, but most ended the same way: stay out of the quiet part of the sea. A private exploration company based in Valparaiso proposed a flyover using synthetic aperture radar. When the plane passed over the zone, nothing unusual was seen visually. But back at the lab, their scan showed a slight distortion across the area. The radar sweep seemed to compress as it passed the center, like space itself had buckled slightly. No clouds, no heat bloom, no known explanation. Eventually, the sector was listed on unofficial navigation maps as low return corridor, not hazardous, not restricted, just quiet. The name stuck, but the ocean didn't offer anything more. Sensors still fail, sound doesn't carry, machines fall silent, and no one can explain why. The bloom that wasn't in the Arabian Sea. For years, satellite images over the Arabian Sea captured something scientists assumed was routine: a seasonal blue, massive swirling patches of green spreading across the water. These phytoplankton blooms were nothing new. The Arabian Sea, like many parts of the ocean, went through regular changes each year when warmer temperatures and nutrient shifts triggered growth. But starting in the early 2000s, something about the bloom began to change. It became thicker, more persistent, and noticeably different in color. From space, it looked like just another sign of ocean life. But up close, it told a darker story. Oceanographers on the Indian research vessel Sagar Nidhi were among the first to raise questions. They noticed that the waters weren't supporting the kind of marine life they're used to. Fish populations were declining in areas that should have been rich in nutrients. The water looked alive, but it was too quiet. No birds diving, no surface splashes. When they sampled the bloom, the truth became clear and far more unsettling. The green clouds weren't made of the usual phytoplankton. Instead, they were dominated by Noctiluca scintillans, a type of dinoflagellate also called sea sparkle. At first glance, this organism doesn't sound especially threatening. It's known for its bioluminescent glow and its beautiful light shows during night surges. But in the Arabian Sea, it was doing something else. Something toxic. Unlike most blooms, which support the food chain by feeding small fish and zooplankton, Noctiluca doesn't play by the same rules. It consumes other plankton, hoards ammonia in its body, and releases toxins that disrupt marine ecosystems. As it spread, the sea began to change. The oxygen levels in the water dropped, leaving vast areas hypoxessentially dead zones. The Arabian Sea, once teeming with fisheries and supporting coastal livelihoods, started to turn into a biological desert. What puzzled scientists even more was how fast it happened. Historical records from Indian Ocean expeditions in the 1980s showed no sign of Noctiluca dominating this region. Even in the early 90s, traditional diatom blooms still played the leading role. But by 2005, this new creature had taken over. Some researchers blamed warming sea temperatures. Others pointed to changing monsoon patterns, which stirred up deeper, nutrient-rich waters in unusual ways. But even combined, these didn't fully explain the scale of the transformation. One research team from Columbia University, led by Dr. Joaquim Goes, tracked the bloom's behavior for over a decade. They published a series of studies between 2013 and 2019, showing that the Noctiluca bloom wasn't just spreading, it was becoming permanent. The bloom no longer came and went with the seasons. It lingered, like a stain on the sea. Goes called it a planetary-scale transformation, something that had effectively re-engineered one of Earth's major ocean systems. Local fishermen had their name for it, the Green Death. They spoke of fish vanishing from once reliable fishing grounds, of engines choking on thick water, of nets returning empty even after long nights at sea. Coastal villages in India, Pakistan, and Oman began to feel the effects economically. But there were also quiet reports of illness, people developing skin rashes, respiratory problems, and unexplained fevers after spending too much time near the water. Still, the global spotlight never fully turned toward the Arabian Sea. The bloom was out of sight, far from tourist coastlines, and easily dismissed as an ecological curiosity. But beneath the surface, the Noctiluca were growing by the billions. Each one carried a pocket of ammonia. Each one contributed to the slow suffocation of marine life. And each bloom meant one less place where life could thrive. In recent years, automated underwater gliders and deep-sea drones have returned more data from the region. What they found was sobering. The hypoxic zones aren't shrinking, they're expanding. Some researchers warn that, if the trend continues, the Arabian Sea could become the largest dead zone on the planet. A body of water once crucial to trade, life, and weather patterns might quietly collapse into something lifeless. What started as a beautiful bloom on satellite images was never just a bloom. It was a signal ignored for too long, hidden behind green swirls and surface calm. The Arabian Sea hadn't come alive. It had started to die. The seabed tracts of the Chagos archipelago. South of the Maldives, in the heart of the Indian Ocean, lies the Chagos archipelago, an isolated chain of coral atolls and submerged banks surrounded by some of the deepest and least explored parts of the ocean floor. It's a remote place, with few ships, fewer people, and almost no commercial activity. But when oceanographers reviewing sonar scans stumbled across a strange pattern etched into the seabed in this region, they couldn't explain it. The patterns didn't match anything seen in nature or known technology. They looked like tracks, massive, sweeping paths pressed into the ocean floor, running for kilometers at a time. The data came from a series of deep-sea mapping missions in the early 2010s. Ships, outfitted with multi-beam sonar, were tasked with surveying the underwater terrain of the British Indian Ocean territory. Most of what they found was predictable ridges, escarpments, underwater volcanoes, but then came the anomaly. Several scans showed parallel grooves carved into the seabed, nearly uniform in width and depth, weaving through a flat section of ocean floor with no apparent cause. At first, researchers thought the marks might be from a towed sonar array dragging too close to the bottom, but when they traced back the ship's movements, they found the vessel had never entered that exact region. The tracks existed independently of any human activity during the scan. That ruled out equipment error. Then came the idea of natural forces. Could tectonic activity, underwater landslides, or strong currents have created them? But nothing fit. The seafloor in that area is stable. The patterns were too clean, too symmetrical, and too wide. Some of them stretched more than 2 kilometers long, and each groove was spaced almost precisely apart, like tire tracks left behind by something massive. The Chagos region isn't well studied. Due to its military restrictions, especially around Diego Garcia's scientific expeditions, they are rare and often limited in scope. But in 2015, a small team from the University of Southampton managed to gain partial access to archived datasets from earlier hydrographic missions. They compared the unusual tracks with known geological formations and man-made activity. Still, nothing matched. What they saw defied expectations: impressions in the sediment, 3 to 4 meters deep, continuing across wide stretches with no starting point and no visible source. Some suggested they could be the result of ancient glacial activity, but that theory was dismissed. The Chagos seabed lies far below where glaciers could have ever existed. Others speculated about deep-sea trawling vessels, but trawlers leave chaotic scars, not neat, parallel trenches. And then there's the fact that these patterns appear at depths greater than 4.0 meters, well beyond the reach of most fishing equipment. The few published reports on the anomaly were vague, often buried in broader geological surveys with little public attention. But among marine geologists who saw the scans firsthand, there was quiet fascination. Something had moved along the sea floor, and whatever it was had left deliberate, continuous impressions. There were no displaced rocks, no sign of propulsion, and no biological explanation. These weren't the markings of a migrating creature or the aftermath of underwater burrowing. They were linear and mechanical looking, the way roads or tracks might appear if built on land. Only they were found thousands of meters below the ocean's surface. Independent researchers who later accessed open-source bathymetric data pointed out similar patterns near other underwater plateaus, but none were as distinct as the ones near Chagos. In online forums and obscure academic circles, whispers began about unregistered submersibles, secret military projects, or something older machines or objects that had passed through long before anyone had started mapping the sea floor. As of today, no official explanation has been released. The tracks remain visible in data collected over multiple years by different vessels. Their depth, consistency, and location rule out every common theory. And since the region is now under tighter control, with most civilian access restricted, the mystery has only deepened. The seabed tells a story, but it's one we can't fully read. There are places in the ocean where strange things happen, moments that science hasn't caught up to, or perhaps simply hasn't wanted to look too closely at. Near the Chagos archipelago, the seafloor still carries marks of something that moved with purpose. Whatever it was, it left a trail behind, and then it vanished. The ghost signals off Point Nemo. Far out in the South Pacific Ocean, thousands of kilometers from any landmass, lies a place so isolated it's been called the oceanic pole of inaccessibility. Point Nemo. It's the spot on Earth farthest from any coast, a stretch of sea so remote that the closest humans are often aboard the International Space Station, orbiting hundreds of kilometers above. For most, Point Nemo is little more than a coordinate on a map. But for deep-sea monitoring stations and acoustic researchers, it has become something else entirely. A place where strange, unexplained signals have been picked up, signals that don't belong. The first hints of something odd came in the late 1990s. NOAA's Pacific Marine Environmental Laboratory, which runs a network of underwater microphones called hydrophones, began capturing low-frequency sounds they couldn't explain. These weren't the kind of rumblings caused by shifting tectonic plates or underwater eruptions. They were structured, rhythmic, and at times eerily mechanical. The signals would rise and fall in precise intervals, often repeating with slight variations. Then, just as quickly, they'd stop. One of the earliest of these sounds was picked up in 1997. It lasted for less than a minute, but what stood out was its originate seemed to come from the area surrounding Point Nemo. The team labeled it the bloop, and although it became widely known, what most people missed was that it wasn't the only one. Over the next several years, fainter signals appeared. Each had its signature, but they all shared a few things in common: ultra, low frequencies, repeating patterns, and no known source. Some resembled the distant hum of engines, others pulsed like coded transmissions. Triangulating the source proved to be inconclusive. One recording would suggest the signal came from thousands of kilometers west, another placed it farther south. The timestamps didn't line up. Some researchers proposed that the sounds could be caused by underwater ice movement, though there are no icebergs in the waters near Point Nemo. Others speculated submarine activity, but the area is too deep, too remote, and too monitored for large-scale human presence to go unnoticed. One proposal came from Dr. Lena Orlova, a Russian-born acoustic physicist affiliated with a joint deep ocean observatory project in Tasmania. In a 2020 article, she suggested the signals might originate from shifting pressure fronts within deep thermoclines layers in the ocean, where temperature changes rapidly with depth. According to her model, if gas pockets were trapped in dense thermal barriers, the release could produce regular low-frequency pulses that resemble artificial sound. But even her theory failed to explain the near-mechanical timing and variations heard across recordings. Nature rarely operates with such precision. Machines do. What complicates the mystery is how quiet Point Nemo should be. The ocean there is among the least biologically active in the world. There are no large coral systems, no bustling ecosystems, and no consistent shipping routes. It's being used as a spacecraft graveyard, where agencies like NASA and Roscosmos deorbit old satellites and space station parts, letting them crash into the deep without harming anyone. But aside from that, there's nothing there at least nothing we've officially acknowledged. Some of the ghost signals appear at night, only once. Others repeat for days. A few, like the one recorded in March 2003, came in short bursts every 19 minutes for nearly a week. Then it was gone. Equipment was checked and rechecked. No faults, the recordings were real. They weren't interfering. The instruments were functioning. The frequency of reports had slowed by 2021, not because the signals stopped, but because research funding shifted elsewhere. Hydrophone networks were decommissioned or redirected to areas considered more critical tsunami warning zones, naval choke points, and regions with commercial interest. Point Nemo went quiet again, but those who had studied its signals remembered. There's a growing theory in fringe circles that the signals are not just sounds, but attempts at communication. Patterns within patterns, frequencies just on the edge of detection. Not random, but intentional. The mainstream scientific community doesn't support these claims, but they also haven't offered a better answer. Point Nemo remains a blank spot on the map, a place where the ocean should be silent. And yet, every so often, something calls out from its depths. A pulse, a hum, a whisper on the edge of human hearing. Whatever is beneath those waters has never surfaced, never shown itself, and never repeated the same message twice. But the sea remembers, and it keeps transmitting. The sunken light grid. Just before descending over a familiar limestone reef south of Malta, the divers noted how calm the sea was: flat water, clear skies, and visibility stretching beyond 25 meters. They weren't searching for anomalies that day. The site had been charted and revisited countless times. But as they drifted lower, something caught their attention beneath the bluer geometric pattern of lights, arranged with unsettling precision. 4 points, evenly spaced in a perfect shape, hovering below them in water too deep for sunlight and far too bright for any known bioluminescent organism. They hovered, unsure if it was equipment or some kind of test array, but no one had reported installations in the area. No cables, no support structures, just open water and rock. The lights didn't waver. They didn't dim or shift like jellyfish or plankton trails. When one of the divers approached, the water remained still, no temperature change, no resistance. He tapped his gauge to check for a malfunction. The lights remained perfectly still. Then, after 15 seconds, they flicked off. Not all at once, one by one. Top left, bottom right, top right, then bottom left. The group surfaced and logged the location. When they returned a week later, nothing was there. No glow, no metal, just sea floor. Their GPS logs were accurate, and the reef hadn't changed, but the lights didn't come back. They assumed it had been a trick of light or a hallucination brought on by depth. But then another group, hundreds of kilometers away, reported the same thing. Off the coast of Crete, 3 commercial divers noticed a faint glow while ascending from a deep dive. They described it as white, sharp, edged, not shimmering. 4 lights again, same spacing. The lights vanished before the divers reached them. They had no cameras rolling. The team said the water felt unusually calm near the lights, with a dull pressure in their ears that eased as they moved away. In Sicily, a spearfisher said he caught sight of a horizontal row of points about 20 meters below him, each one fixed like a marker buoy, but without the tether. He dove down to check and said they looked embedded in the rock, flush with the stone surface. But he didn't reach them. They went dark when he was still 10 meters above. Word started to spread through tight-lipped diving communities. Some dismissed it as sensor reflections, perhaps underwater drones testing new LED systems, but others pointed to details that didn't fit. No propeller noise, no light spread, no shadows. A researcher from the University of Naples compared field reports and noticed the grid shape was always the same, rectangular or diamond, patterned, rarely circular. He proposed it might be linked to undersea fiber optic systems, but no known cables ran through those specific areas. One diver suggested it could be a visual distortion or a biological effect, but the shape and symmetry didn't match anything familiar. A local diver described them as mechanical-looking but too deep for cables or lamps. If they were man-made, they were installed without permits, without records, and without power lines to feed them. Sonar sweeps of the known coordinates picked up nothing. No ridges, no outcrops, just flat, undisturbed sediment. Remote-operated vehicles were sent in a few cases, but none found anything unusual. In one instance, a submersible camera briefly showed light reflecting off something smooth, but the feed cut out seconds later. When they recovered the drone, its storage was intact, but that frame was missing from the footage. The precision of the lights was disturbing, but the silence made it worse. No hum, no mechanical vibration. Divers said the water near them felt compressed, like everything had gone still. One even compared the sensation to being observed. That phrase came up more than once in independent interviews. Later efforts to track the grid using satellite-based spectrometry produced no useful data. Infrared showed no heat blooms. LiDAR scans revealed only shallow contours, as if the terrain refused to give detail. A few private research teams theorized that the lights were part of a military decoy or classified project, but no country stepped forward with confirmation, and no base locations were ever linked to the reports. Reports of the sunken grid still appear in dive logs, and second-hand accounts always below 30 meters, always in lines, and always gone when revisited. The unreachable signal from Challenger Deep. In the Mariana Trench, where the Pacific seafloor plunges nearly 11 kilometers down, the water turns cold, black, and crushing. Few machines can survive there. Fewer still can function long enough to listen. In 2015, one of them did. An autonomous deep-sea recorder, deployed by the National Deep Submergence Facility in partnership with NOAA, was lowered into the trench for a 30-day mission. Its job was simple: to gather ambient sound data from the Challenger Deep, the deepest known point in the ocean. What it brought back was something no one expected. For most of its deployment, the recorder captured what researchers anticipated: distant rumbles from seismic activity, faint clicks from bioluminescent organisms, the groans of shifting plates far below. But tucked between these familiar noises was something else. A short burst of sound barely above the noise floor emerged at 3:17 UTC. On the 18th day of the mission, it lasted only 8 seconds. Then, after a brief silence, it came again. Slightly different, slightly louder. It repeated 3 more times over the next hour, each time with subtle changes. Then nothing. It was never recorded again. The signal didn't behave like any kind of biological call. No known species produced vocalizations with this kind of structure, and the irregularities typical of marine communication were completely absent. It wasn't seismic either. The waveform revealed something different: smooth rise and fall curves, consistent frequency bands, and a type of modulation that suggested design. The pattern was rhythmic, but not in any way that felt natural. More like a transmission measured, deliberate, and somehow wrong for the deep. Back on the surface, the data was processed by a team at Woods Hole Oceanographic Institution. The technician who first flagged the signal, Grace Hanley, described it as eerie but precise. Like something that was meant to be heard, but not understood. When analysts tried to match it against known databases' naval equipment, whale song, geological tremors, they came up empty. The pattern didn't align with anything artificial either. There were no harmonics from propellers, no acoustic signatures of submarines or undersea drills. replicating the signal proved impossible. Several months later, a follow-up mission dropped another recorder to the same location. That one stayed for 40 days. It picked up nothing unusual. Not a single repeat of the strange transmission. The team widened the search radius, placing hydrophones at 3 additional points along the trench in early 2016. Still, silence. Whatever it was, it had only spoken once. There was speculation about an equipment glitch, the kind of malfunction that might inject stray data into the recording, but the recorder had passed all post-retrieval diagnostics. Its internal clock, sensors, and storage systems were intact. There were no data losses, no signs of electrical interference, and no distortions elsewhere in the log. The signal had been clean, uncorrupted, and captured. Others proposed a geological explanation, a rare type of rock resonance triggered by an unknown pressure shift. But even that theory lacked supporting data. No tremors, no movement, no thermal anomalies were detected before or after the signal. The ocean floor, according to satellite altimetry and deep sonar scans, had remained still. Challenger Deep is not just deep, it's almost unreachable. The pressure exceeds 10 times that at the surface, and even the most advanced machines can barely survive there. Few human descendants have ever succeeded, and no infrastructure reaches that far down. It's one of the quietest places on Earth, and yet, something made itself heard. A few years later, a team from the University of Tokyo attempted a new expedition using more advanced sensors. Their probe failed, 400 meters down in 2017, crushed by unexpected pressure despite being rated for even deeper exploration. Some blamed a manufacturing flaw. Others quietly noted that a similar model had worked fine in shallower parts of the trench just months earlier. Since then, interest in the anomaly has faded. Funding moved on to more practical projects, coastal erosion, climate monitoring, and fisheries management. The signal from Challenger Deep remains a footnote in acoustic archives, labeled only as Unresolved Event 2015-3. There are places in the ocean where even our most advanced tools can only listen, and even then, just barely. In one of those places, at the farthest edge of what we can reach, something called out once. A voice, a pulse, a pattern heard only by a machine drifting in the dark. And then, silence. The slow-down sound. Deep in the South Pacific Ocean, a long, descending sound was recorded by NOAA's underwater listening network cone that in 1997 began high and fell lower and lower until it disappeared. It began too sharply for a whale, too smoothly for an earthquake, and slowly dropped in frequency over several minutes, as if something massive were losing momentum in deep water. The sound wasn't short and it wasn't scattered. It traveled with weight, cutting across thousands of kilometers before fading. The team that captured it gave it a simple name, the Slow Down. On May 19, autonomous hydrophones spread across the eastern Pacific captured something unusual from the deep. The source wasn't near the surface. It seemed to come from far below, well past the reach of normal weather noise or surface interference. Analysts at the Pacific Marine Environmental Laboratory were the first to examine it in detail. The waveform showed a smooth, unbroken arc, starting in the higher frequencies and gliding steadily downward, like a deceleration too slow and steady to be natural. One early theory pointed to ice, possibly a large iceberg scraping along the seafloor, but the coordinates didn't support that. The sound came from an area far from known ice activity. And while glaciers can sometimes produce long groans when they fracture or grind, those events are jagged and irregular. This wasn't. The Slow Down had a structure, a pacing, and a reach unlike any cryoseismic event NOAA had ever recorded. The signal was strong enough to be detected by multiple hydrophones spaced more than 50 kilometers apart. Whatever caused it, it was loud. There were no earthquakes at the time, no seafloor eruptions, no storm systems nearby, just the signal starting strong, drifting downward, and then gone. The total duration was about 7 minutes. Long enough to rule out most natural explanations, and too smooth to match anything mechanical. It didn't echo like submarine engines or undersea construction. And it wasn't followed by any aftershocks or secondary signals. It came once, left a mark in the data, and never returned. When the NOAA team attempted to narrow down its location, they found it had originated from somewhere south of the Pacific Antarctic ridge. This is one of the most remote, least explored stretches of ocean on Earth, a place with no permanent monitoring stations, no shipping lanes, and no significant recorded seismic activity. The closest landmass is more than 500 kilometers away. It is, by every known standard, empty. In the years that followed, Slow Down became one of a handful of unexplained underwater recordings archived by NOAA. Alongside others like Upsweep and Julia, it's often cited in studies about unexplained acoustic anomalies. But unlike those, which have returned sporadically or lasted for longer periods, Slow Down happened once. That rarity only deepened the mystery. Some believed it might have been a mechanical failure in the equipment, but multiple sensors recorded the same signature with consistent timing and amplitude. No corruption, no drift, no data loss. Marine biologists were consulted, but none could name a known animal that could produce a sustained, descending tone of that power and length. Even the largest whale's blue or findant creates signals that last minutes without breaks, especially ones that drop so gradually across such a wide frequency range. Seismologists were equally stumped. No known geological event fits the pattern. The rate of frequency change was too linear, too calm. If it had come from the Earth itself, it did so in a way we've never observed before. Speculation spread into less conventional circles. Some wondered if the sound was the result of a massive object moving through deep water, something not designed for speed, but with mass and resistance, slowing against the pull of the sea. Others pointed to the trench systems in that part of the ocean, particularly the South Sandwich Trench, and proposed that the noise could be something falling, something heavy, deep, and unnatural. NOAA never endorsed any of these ideas. They simply archived the recording and labeled it as unexplained. To this day, no similar signal has been recorded. The original Slow Down file remains available in NOAA's online public database, where it's occasionally studied by new researchers looking for overlooked details. But none have found a clear match. The data remains clean. The origin remains unknown. The Slow Down was heard once, recorded by chance, and never again. Its source remains buried somewhere in the deep, unrepeated, unclaimed, and unexplained. The disruption of the Gulf Stream. For just over 9 minutes in late July 2021, something happened in the Atlantic Ocean that shouldn't have. The Gulf Stream, one of Earth's most powerful and stable ocean currents, briefly reversed direction. Not slowed, not redirected, but fully reversed. It wasn't a computer glitch. It wasn't a misreading. Multiple monitoring points along the mid-Atlantic picked it up, a complete inversion of flow. And then, just as quickly, it shifted back. The Gulf Stream is no ordinary current. It's a vast, consistent conveyor of warm water that flows from the Gulf of Mexico up the eastern seaboard of North America, then arcs across the Atlantic toward Europe. It stabilizes weather patterns, fuels marine life migration, and helps regulate the planet's climate. Its speed fluctuates naturally. It can pulse or slow depending on seasonal shifts, salinity, or glacial runoff, but it doesn't stop, and it doesn't turn around. A group from the Woods Hole Oceanographic Institution was reviewing live data from pressure and current sensors anchored along the stream on July 27. Just after 14:00 UTC, one node flagged a velocity reversal. At first, it was dismissed possibly local turbulence or a misfire in sensor calibration. But then another node, farther north, showed the same reversal. Then another. Over the next 90 seconds, 5 monitoring stations between Bermuda and the Azores confirmed it. The current was flowing in the opposite direction, not slowing, not cycling, reversing. The reversal didn't last long. Exactly 9 minutes and 14 seconds after it began, the flow returned to normal, the sensors recalibrated, and the system continued without disruption. But what made the event alarming was the absence of any trigger. Reversals of major ocean currents are typically tied to extreme atmospheric or geological events, like hurricanes, major shifts in wind systems, or underwater earthquakes. In this case, there were none. No external force to explain what had just occurred. Weather satellites showed no anomalies. The skies above the Atlantic were calm, with scattered clouds and average pressure. no seismic stations in the region reported any tremors or movement. There was no undersea landslide, no sudden ice melt, no change in salinity or surface temperature. The ocean had simply changed direction, held it, and let go. The event was quietly logged as transitory flow reversal, Atlantic node chain. It wasn't made public at first, mainly because there was no clear explanation. A few weeks later, internal reports were circulated between NOAA and a small number of research institutions. A working group was formed to assess the anomaly, led by Dr. Ilana Perrault, a fluid dynamics specialist based in Marseille. She described the event as hydrodynamically improbable, but undeniably recorded. Her team ran simulations using various conditions: massive underwater eruptions, sudden atmospheric shifts, even passing gravitational waves. None produced the same pattern. Nothing fit the data. The reversal wasn't chaotic. There were no signs of turbulence or disrupted eddies. It was smooth, measured, controlled, as if something had simply pressed pause and spun the flow backward. The clean nature of the data disturbed several analysts, particularly those familiar with man-made systems. Some noted that it resembled artificial current inversion testing conducted in closed-loop marine environments, like flow tanks or hydrodynamic labs. But this was open, ocean-vast, uncontrolled, and free of containment. And no such technology exists at that scale. A naval liaison attached to the group later confirmed that no submarines, drills, or classified underwater operations were known to be in the area at the time. All shipping traffic logs were routine. The sensors themselves were double-checked and passed all diagnostic checks. Batteries, data timestamps, internal clocks all in sync. The equipment had worked as intended. The event had been real. A second reversal has never been recorded. Months of extended monitoring in the same region showed nothing unusual. The Gulf Stream continued its path, pulsing as expected, without repetition. But the anomaly remains in NOAA's archives. There is no known natural process that can reverse such a massive current that briefly, that cleanly, and leave no trace behind. Theories have surfaced: unusual magnetic shifts, gravitational interference, even pressure dynamics beyond current models, but none have held up under review. The same flow that shapes weather systems and warms entire continents reversed itself for less than 10 minutes. No one knows why, and no one knows if it will happen again. The lost submarine pings of the South Atlantic. In the waters between the southern tip of Africa and the coast of Brazil, sonar operators have been hearing something they can't explain. Short, sharp pulse each, lasting less than 2 seconds, bounce through the deep and vanish. They come in pairs or trios, perfectly timed, spaced apart by intervals too exact to be natural. To trained ears, they sound like standard submarine pings, but whenever vessels are dispatched to investigate, there's nothing there. The first known report came in early 2006 from a Brazilian naval monitoring station near Ilha da Trindade. A routine sweep picked up a 3-pulse echo just south of the mid-Atlantic ridge, consistent with an active sonar sweep from a fast-moving vessel. Contact was lost after 90 seconds. No surface ships were in the area. Satellite tracking showed no nearby activity, and Brazil's submarine fleet reported no operations in the region. The event was marked as unexplained and shelved. But it didn't stop. Over the next several years, similar pings were detected in deep-water corridors between South Georgia Island, Tristan da Cunha, and the Argentine Basin. Always the same, clean pulses, separated by precise gaps, echoing at depths that matched known submarine activity, but with no corresponding craft, movement, or wake. The pulses never lasted long. Most were logged at under 4 minutes, never exceeding a 5-kilometer sweep radius. No signatures of propulsion, no thermal trails, just the sound, and then silence. By 2012, the frequency of these detections had increased enough to prompt joint monitoring between Argentina, South Africa, and Brazil. Several of the zones where these echoes were heard overlapped with restricted waters classified areas used for naval training, weapons testing, and submarine exercises. This led some to assume the source was simply an unacknowledged foreign vessel, but analysis of the echo patterns complicated that theory. The intervals were consistent across multiple recordings, yet not aligned with any known NATO or Eastern Bloc frequency structures. They weren't encrypted, distorted, or shielded like stealth subs typically are. They were loud, open, and rhythmical, most like they wanted to be found. 2 years later, the Argentine Navy compiled a report covering 38 separate events across 8 years. One of the most detailed came from December 2013, when an Argentine research vessel, the Puerto Deseado, was conducting deep-water mapping near the Malvinas Plateau. The ship's passive sonar picked up 4 pings in rapid succession at 200-300 meters. The signals were triangulated to a stationary point about 11 kilometers away. When the crew moved to intercept, the pings stopped. A probe was deployed. It recorded nothing unusual, no metal signatures, no changes in temperature or salinity. The seafloor was undisturbed. South Africa's Navy experienced a similar event in 2016, while running drills near the Walvis Ridge. Submarine SAS Queen Modjadji picked up a ping just before entering a deeper trench. The onboard sonar officer identified it as a short-range sweep, something a submarine might use to gauge underwater terrain. The area had been cleared of all vessels. After the ping, there was nothing. No more echoes, no follow-up activity. The signal was archived as unidentified. Explanations for the phenomenon generally fall into 3 main categories. One argues that these are fragments of long-distance sonar reflections from legitimate naval exercises, distorted by deep-sea layers and arriving out of sync. Another claims they're the result of naturally occurring undersea features, volcanic ridges, or moving sediment layers that reflect acoustic energy in patterns we don't yet fully understand. The third camp believes these are signals deliberate, controlled, and not from any known military power. A handful of analysts have pointed out the uniformity of the pings. Unlike sonar reflections from whales or geological activity, these pulses have tight frequency bands, clean onset and decay curves, and a precision that implies construction. One British report suggested the source behaves like a mobile system, repositioning across months but never surfacing, never sending follow-up pings. That level of restraint doesn't match any known patrol strategy. It's more like observation. Despite the growing archive of recordings, no country has claimed ownership or found a physical source. No acoustic trail ever leads to an object. No visual confirmation has ever been made. Just short bursts of sound in the deep, repeating across years, heard by machines and logged in silence. In the classified sonar archives of multiple nations, they now have a name: Echo Type Delta. No one knows who or what is responsible. But somewhere in the cold, dark pressure of the South Atlantic, something keeps pinging, and it doesn't want to be seen, just heard. The lights of the Aleutian Abyss. 10,000 feet beneath the surface of the North Pacific, in one of the deepest sections of the Aleutian Trench, a remote-operated submersible recorded something it was never designed to find. What first appeared to be a flicker in the dark soon revealed itself to be something more structured, deliberate, and strange. Cold white points of light, blinking in rhythm, not randomly precisely. Over 3 minutes, they pulsed in a sequence that closely resembled binary code. The footage came from a 2018 expedition led by the Monterey Deep Sea Initiative, a joint venture between US and Japanese researchers studying tectonic movement near the Kuril-Kamchatka Trench and the broader Aleutian subduction zone. The submersible ROV Kaio 7 was equipped with low-light HD cameras, precision magnetometers, pressure gauges, and a standard acoustic array. It was descending along a gradual slope at roughly 350 meters when its live feed captured the first blink, a small point of light, hovering about 20 meters ahead of the camera's view. It flashed once, then twice, quickly, then paused. At first, the surface team suspected a reflection, or perhaps a bioluminescent organism reacting to the ROV's presence. But a second blink followed, identical in spacing, 6 seconds later, then another. The lights appeared to hover in a vertical arc. As the vehicle crept forward, more pulses appeared. The pattern, when later transcribed, was non-repeating, structured, and suggestive of encoded information. Enough to raise questions, but not enough to decode. On review, researchers noted how sharply defined the pulses were. They didn't fade or flicker like natural glows from deep-sea jellyfish. They were bright, uniform, and precisely timed. Stranger still, they left no trace on thermal or acoustic sensors, no heat signature, no sound. Only the cameras recorded them. And when the ROV advanced toward the source, the lights went dark. The surrounding water remained still. No disturbed sediment, no displacement, no movement of any kind. The ROV hovered, scanned, and found only empty seafloor. A follow-up sweep using multi-beam sonar, LiDAR, and narrowband acoustic imaging revealed nothing unusual: no structures, no mineral formations, no life forms known for advanced bioluminescence. Whatever had emitted the lights had disappeared completely. Environmental data showed nothing out of place. Pressure, salinity, and temperature levels matched expected norms, no fluctuations in current. The ROV's diagnostics showed no malfunctions, no imaging artifacts, no electrical interference, and no data corruption. Every instrument operated as expected. The onboard log from that session recorded full voltage stability, GPS lock on the support vessel, and no anomalies in navigational drift. The team returned in early 2019 with upgraded optics, a higher frame rate imaging system, and a wider scanning field. They revisited the exact coordinates, ran repeated visual passes, and combed the surrounding trench walls and shelf outcroppings. No lights returned, nothing blinked. There were no anomalies, no echoes, no unusual chemical readings, not a single signal. One theory suggested an undiscovered species capable of controlled luminescence, but biologists were doubtful. Most bioluminescent patterns serve known purposes: luring prey, deterring predators, and attracting mates. They're messy, adaptive, and often organic in timing. These lights had structure, clarity, and discipline, something natural systems rarely display in such form. Another group considered mechanical reflection, perhaps from particles or equipment artifacts, but the consistency of the interval sound, the complete lack of environmental disturbance, challenged that too. Each pulse had a sharp onset and clean decay. No scattering, no distortion, no secondary light halo in the water column. An analyst at the University of Tohoku ran the footage through VLF signal analysis software, which flagged the blink intervals as similar to communication formats used in long-range underwater transmission. These signals typically originate from naval platforms or scientific instruments, but in this case, no transmitter was found, no acoustic origin, no human presence had been logged in the area at the time. The Aleutian Trench lies far from undersea infrastructure. No military drills were reported, and no oceanographic experiments were active in the region. There are no fiber lines or seismic networks within range. By every available measure, the ROV had been alone. The footage was eventually archived under the label Visual Anomaly, Binary Characteristics. It still exists in internal databases, occasionally reviewed but never explained. The lights blinked, paused, then disappeared like a message left in the dark, its sender and meaning still unknown. The drag marks across the ocean floor. At a depth where sunlight has never touched and pressure could crush steel, a research expedition stumbled onto something that didn't belong. While conducting a sonar mapping survey of the South Pacific seafloor in 2015, a team aboard the Kyrei, a Japanese deep-sea research vessel, noticed strange inconsistencies in the data. What looked at first like linear depressions turned out to be something far more unusual: wide, continuous gouges stretching across the ocean floor. Not just one or two, but a series of them, running nearly parallel for dozens of miles. Some were shallow, others cut deep into sediment layers that hadn't been disturbed in thousands of years. The gouges varied, some nearly 6 meters wide, dipping over 2 meters into the soft sediment. Others seemed fresher, with raised ridges along the edges as if something enormous had passed through recently, dragging with weight and direction. The patterns were too structured to be random, yet too irregular to be a part of any known geological fault or tectonic shift. The trench where they were discovered lies over 4.0 meters deep, near no known mining activity or undersea cables. Nothing should have moved with that force, that straightness, at that depth. The Kyrei team logged the coordinates and conducted a follow-up with side-scan sonar to produce higher resolution images. The visuals showed striations, grooved tracks flanked by disturbed sediment. They weren't shaped like lava flows or glacial scrapings. No signs of volcanic activity or plate movement appeared. No seismic event had been recorded that could account for such linear displacement, just gouges. Long, heavy, and seemingly deliberate. In the following months, researchers at JAMSTEC, Japan's Agency for Marine Earth Science and Technology, reviewed data from earlier surveys. A 2003 mapping mission in the nearby Tonga Trench showed a similar patternless, extensive, but unmistakably related. Two parallel trails, each about 4 meters across, spaced evenly like tracks left behind by twin treads. At the time, they had been dismissed as artifacts of outdated sonar resolution. But with new imaging, they matched almost exactly. Speculation began to circulate about what could cause such marks. Ancient landslides were considered, but sediment layering ruled that out no buildup, no debris fan, no source slope. A drifting glacier dragging debris from a distant polar region was also proposed, but the location made that implausible. The trench lay thousands of kilometers from the nearest glacial shelf, and no known currents could have delivered such a massive object undisturbed. Marine life was considered. Even the ocean's largest creatures, like giant squid or deep-dwelling sharks, have been found at similar depths, but nothing biological explains these gouges. The spacing was too broad, the direction too consistent. Whale carcasses are known to sink and shift along the ocean floor, but they leave behind irregular indentations, not straight-line trenches that stretch for kilometers. There were no bones, no remnants, no trace of decay. One team from the University of Western Australia proposed a mechanical explanation. Their theory involved a lost deep-sea probe or failed equipment module, dragged by a current or caught in an undersea slump. But no records matched. No device had gone missing in the region, and the required mass to leave those tracks would have demanded a size and density far beyond any unaccounted object. More importantly, the trails didn't end in debris or an impact point. They just stopped, as if whatever made them had lifted off or vanished. A private oceanographic firm conducting mineral surveys near the same trench in 2017 reported a new set of gouges shorter but deeper and intersecting with one of the earlier paths. Their ROVs filmed the trench directly. No debris, no tools, no recognizable features, just disturbed sediment trailing off into darkness. The gouges were not made public, not officially, but they've appeared in restricted conference briefings, quietly passed between institutions. The working theory? Unknown movement, possibly mechanical, possibly not. Something that travels along the seabed not drifting, but choosing a path, and heavy enough to cut through mud and rock without slowing. Today, these marks are logged under generic file codes in bathymetric archives. No names, no classifications, just coordinate strings and depth profiles. The area remains unmapped in high resolution beyond those passes. Whatever carved those paths left no signature but the trail itself. No sound, no signal, no residual heat or radiation. Only the imprint remains etched into the deep, perfectly silent, as though something unseen had walked across the ocean floor. The Hadal flash beneath the Kermadec Trench. The Kermadec Trench cuts deep into the Pacific seafloor northeast of New Zealand, a cold, crushing zone few instruments have ever reached. It plunges beyond 0 meters far past where light can travel, where pressure distorts metal, and silence is nearly total. In 2019, an unmanned probe sent to survey this depth recorded something that has no place in that world. A burst of light brief, intense and unaccounted for, flared through the water. The mission was part of a joint program between the Japan Agency for Marine Earth Science and Technology, JAMSTEC, and NIWA, New Zealand's National Institute of Water and Atmospheric Research. The probe, designated HOV-4, was designed to passively observe seafloor sediment movement and temperature shifts along tectonic fault lines in one of Earth's most remote and geologically active zones. It carried optical sensors, low-light cameras, and a suite of passive monitoring instruments calibrated for deep-sea anomalies. At 3:42 UTC, on March 9, the probe was hovering just above the trench floor at a depth of 112 meters. For the previous 7 hours, all logs had been routine. Then, without warning, the light sensor spiked. For just under 3 seconds, it registered a sharp rise in local illumination, so strong that the automatic gain control briefly maxed out. The onboard camera caught it too, A white flash filled the left side of the frame, stretching across the water column before fading. Nothing preceded it. Nothing followed. The probe's internal diagnostics showed no malfunction. There was no battery surge, no LED activation, no magnetic disturbance. Redundant sensors confirmed the flash was external. The camera lens had not been exposed to backscatter, nor were there any signs of electrical arc. The pressure sensors showed no shift. In every other way, the environment remained stable and undisturbed right up until the light appeared. When the data was transmitted and reviewed on shore, researchers assumed a logging error, but multiple backups recorded the same event. The light wasn't an illusion or a reflection. It was real, and it had occurred in a place where light simply shouldn't exist. Bioluminescence was briefly considered, but deep-sea organisms emit faint, often blue-green pulses used for mating, camouflage, or prey attraction. None produces light at this intensity or speed, and none are known to live at that extreme depth. The flash did not match any natural patterns of marine signaling. It lacked color modulation. It was stark white, with a sharp onset and fall-off curve more like artificial illumination. Geological explanations fared no better. No seismic activity had occurred in the region for weeks. There were no nearby hydrothermal vents, no methane eruptions, no documented gas releases. Those kinds of events tend to cloud the water, disturb sediment, or produce chemical traces. Here, the water column remained clear and undisturbed. Another probe launched to the same coordinates 11 days later found no visual anomaly, no disruption to the seabed, and no repeat of the flash. Water samples taken at depth returned nothing unusual. Salinity, pH, and temperature were unchanged. The sediment showed no recent disturbance. No thermal traces remained, and no background radiation levels exceeded norms for the region. Several researchers compared the light profile to known artificial sources. One possibility raised was a deep-sea electrical discharge, perhaps a power failure in a previously unknown wreck or probe. But no equipment had been lost in that sector. There were no sunken vessels, no black boxes, no debris on sonar. The nearest known crash site lay more than 800 kilometers away. One analyst from the University of Tasmania proposed that the flash bore similarities to strobes used in autonomous navigation systems, but such systems would require a host device, and if one had been present, it should have triggered sonar or acoustic signatures. Nothing had. The footage and sensor logs were quietly circulated between partner institutions. Though it remained unannounced to the public, it found a name in internal databases: Event KT19. The designation simply marked its time and locaciono explanation, no assigned category, and no evident cause. Its origin remains unexplained even now. There is no accepted theory, no model that fits. Something far below the edge of human reach released a burst of light. Not heat, not pressure, just visibility out of nowhere, for 3 seconds, and gone. In a part of the world untouched by sunlight since the beginning of time, something shone. The unexplained clicks beneath the Ross Sea. In the cold waters off Antarctica, where the seafloor drops sharply into the Ross Sea abyss, something was heard moving that no one could see. A pattern of clicking pulses, sharp, fast, and unnervingly pressure-traveled across hydrophone networks, placed to monitor iceberg movement, cetacean migration, and under-ice seismic shifts. These weren't echoes from whales or ice fractures. They moved with purpose. They followed no known pattern. The first sequence was logged in July 2016, when darkness covered the region nearly 24 hours a day. At a remote monitoring station southeast of Beaufort Island, hydrophones maintained by NIWA and the British Antarctic Survey picked up a clean acoustic burst: 4 quick clicks, a short pause, and then 4 more. Each pulse lasted less than 30 milliseconds, yet all shared identical frequency and shape. The interval between bursts, 1.7 seconds, remained perfectly consistent over nearly 9 minutes. What stood out wasn't just the timing, but the movement. The signal transitioned between 5 hydrophones spaced along the western slope of the Ross Sea basin, covering almost 40 kilometers in just under 5 minutes. That velocity suggested something faster than any known marine animal at that depth, and yet it never created wake noise or turbulence, typically associated with propulsion. The initial theory pointed to a biological source. Many deep-diving species use echolocations. Perm whales, beaked whales, and some species of squid, but the waveform didn't match. Whale clicks typically vary with age, behavior, or stress. These didn't. There was no fading with distance, no environmental distortion. Everything about the signal suggested something artificial, but no vessel had been registered in the area, and no research activity was logged at the time. During analysis, researchers noticed the frequency sat narrowly within a band, typically reserved for acoustic telemetry, a system used by some oceanographic instruments to send data wirelessly through water. But the spacing between pulses didn't match any known telemetry code. It lacked handshaking signals. There was no source ID, just raw bursts of sound, cycling over and over. 3 months later, another occurrence. This time, the source was near the Balleny seamounts, further east, near a deep trench that had only been sparsely mapped. Again, the pattern emerged: 5 clicks. A gap, 5 more. But the spacing had changed, 2.3 seconds this time, and the waveform was slightly compressed. It moved northeast, passed over 2 recording stations near the slope of the continental shelf, then vanished without a trace. Using digital analysis tools, the Otago team examined both sets and detected something that didn't quite fit. The frequency drifted by less than 0.01 Hz over long distances. That kind of consistency is nearly impossible in natural systems, where sound travels through layers of variable temperature, salinity, and density. These signals cut through with no wobble, as if they were stabilized by some kind of internal control. Not long after, acoustic specialists began comparing the pattern to early underwater signaling protocols, specifically those used before broadband modulation became common. The spacing mirrored legacy frequency shift keying models, but there was no hardware present to send it. No infrastructure, no relay, no listening station, just open sea. Other explanations emerged. Some suggested that the clicks came from deep geological interactions, subduction events, or methane vent activity. But no tremors were recorded, and the sound moved laterally, not vertically. It also stayed within a narrow depth band between 3,600 and 3,800 meters, just above the abyssal plain but far below any biologically active zone. A naval contact from Hobart confirmed no military assets were in the region. Under-ice drone missions had ended months prior. There were no missing submarines, no hardware tests, and no communication buoys in range. The signals were logged under the name RSC-16 and flagged for review, but the source was never traced. Subsequent passes through the same area have turned up nothing. Even with upgraded hydrophones installed in 2018, the seafloor remains quiet. No follow-up pattern, no drift, just a series of archived clicks, preserved in lossless format and replayed over and over by researchers trying to hear something new. Some anomalies leave heat, some leave debris. This one left only timing pulses clicking into the dark, repeating across kilometers, without cause or trace. Whatever moved beneath the Ross Sea didn't want to be seen, only heard.